Hey, math friends. So our learning target today is I can review the geometry unit. So everything we did in the geometry unit with circles and cylinders. All right, so starting first with the review of some language on radius and diameter. Remember we talked about the radius is the line that goes from the center to the rim, and the diameter is the line that goes from side to side passing through the center. So what is the diameter here? Well, the diameter is the line that goes from side to side passing through the center would be AC. So the diameter is AC. In the circle shown, how long is the radius? Well, we know the diameter is 24. So we're going to take 24 divided by 2 to get the radius. So that means that one of these is 12, the other one is 12. So the radius would be C, 12. If the radius of the circle is 32, how long is the diameter? Well, then it's 32 plus 32 would be 64. So this first learning target, we're just talking language or vocabulary. In the circle shown, which is not a radius of the circle? So this is a radius, that is a chord actually. So OB is a radius, AC is a diameter. So let's see what we got here. BO is a radius. OC is a radius. AO is a radius. So the only one that is not the radius of the circle would be AD. It's actually called a chord. That's actually what we call it, as a chord. A diameter is said to be 2 times the radius. If the radius is 26, what is the diameter? Well, that's a 26 plus a 26, which is a 52. So answer should be A, 52. A radius is 1/2 the diameter. So if the diameter is 30, how long is the radius? Well, that would be 15 and 15. So the radius then would be 15b. So vocabulary on just radius and diameter. And then moving to area and circumference. So we said in the circle sign, pi r squared sounds like area to me. And we're talking area, we're talking space inside. Pizza sauce. So area is measured by pi r squared sounds like area to me, which is 3.14 times the radius. So from center of the circle to the inside of the circle would be 3 squared. So you can either put that all in your calculator, or some kids would prefer to maybe do the exponent first in their head, or you just put it all in your calculator. It doesn't matter. So if I do that first, I get 9 times 3.14, or you can just type it in, 3.14 times 3 squared, and you get 28.26. The units on that is centimeters squared. Now, sometimes they'll ask you to leave your answer in terms of pi, so I'm going to do that as well. So if we left this as pi, that then would be 9 times pi, which is the same as 9 pi. So 9 pi has the same answer as 28.26, just some language there. Sometimes they ask us just drag the pi with us. Like do all the other math, which is 9 pi. Just be aware that that happens sometimes. Find the area. All right, so it looks like in this particular problem that the diameter is 12, or is 24 rather. So therefore the radius is 12, because that would be a 12 plus a 12. So pi r squared sounds like area to me, would give me pi times 12 squared. Again, pause the video. We've talked about this a million times. Write it down, pause the video, then push play. Try to solve it, then push play. Did you get it right? So one way to write that is 144 pi. And the other way is just to simply type that all in your calculator using 3.14. 3.14 times 12 squared is 452.16 inches squared. And again, I use 3.14 for pi. So that's area, space inside. I gave you one example where you're given the radius and one example when you were given the diameter. For area, you need radius. Now, what about circumference? Circumference is the crust, right? The distance around, kind of like the perimeter of other shapes, which you're good at. When I need a circumference, I'll just use pi d. So that's 3.14 times the diameter. And in this case here, it would be 5 plus 5 would be the diameter, which is 10. So that gives me 31.4 inches, singular inches, because we're just talking the distance around something. It's not squared. Other possible answers is that you could leave this as a pi symbol and that it could be 10 pi is another way to write that answer. Just be aware of that. Could come up as well. So circumference, when I need a circumference, I'll just use pi d. Make sure you actually have a d in your formula. So notice I did 5 plus 5 to get the diameter. I was given the radius. When I need a circumference, I'll just use pi d. So that's 3.14 times the diameter. I ran out of space there. Diameter is the line that goes from side to side passing through the center is 4.8. So circumference is 3.14 times 4.8 is 15.072. If we were to cut that off then, that's 15.07. So the circumference approximately equals 15.07. That is the distance around that circle. The units on that would be centimeters. Find the arc length. So we're talking about crust still, but just part of the crust, and we want the shaded region. So this part right here. So first of all, recognizing that that's 1/4 of the circle. So when we talk about the crust, we say when I need a circumference, I'll just use pi d. But this time we're just going to throw a 1/4 in the front of there. 1/4 of the circumference, called arc length. What's the length of this arc? So the rest we're just plugging in. When I need a circumference, I'll just use pi d. 1/4 of it for that section, that's 3.14 times the diameter. Well, the diameter is really then 3.6 plus 3.6. 3.6 plus 3.6, you can use your calculator for that, is 7.2. So it's 1/4 of pi d. And when you type this in, you just can simply type 1 divide 4. 1 divide 4 on your calculator, times that, times that. So I'm getting that the circumference of that arc is 5.652. If we cut it out to the hundredths place, then the circumference of the arc would be 5.65 meters. So this distance right here is 5.65 meters. I'm going to verify that real quick in my calculator, make sure I typed it in right. Boom, nailed it. All right, next problem. What is the arc length? The shaded region would be 1/2. So we're still talking about the crust or the distance around, but we're taking 1/2 pi times the distance across. The line that goes from side to side passing through the center is 20. Again, 1 divided by 2 times this times that would be 31.4 millimeters, just millimeters, because we're just talking about what's the distance here. That's called arc length when we're taking part of the crust, arc length. Okay, moving on here to the next slide. Find the area of this sector. So what's left of the area would be 1/2. Area is measured by pi r squared. Sounds like area to me, but we only have 1/2 of it for the shaded. This should say shaded in my directions. I kind of forgot that part. Shaded region. So area is measured by 1/2, 3.14 times the radius squared. Well, the radius then would be 10 because this would be a 10 plus 10 diameter. So 10 squared. So area is measured by all of that. So 1/2, 3.14 times 10 squared gives us 157 millimeters squared is the area of 1/2 of the circle. All right, keep going. So this is 3/4 of the circle, that's not going to work when I do that. But if I break this into 4 pieces, I lost my pen. Where is it? Ah! If I break this into 4 pieces, you might be able to see it a little better. That we're representing 1, 2, 3/4 of the circle for this shaded region. So area is measured by 3/4 pi r squared. All right, so when we do that, we get 3/4 times 3.14 times the radius squared. And the radius is this distance right here, which is defined as 4. So it's just a calculator problem. Again, when you're typing this in, it's just 3 divided by 4. You can also put it as a decimal if you want, but so 3.14 goes in for pi times 4 squared. So that gives you 37.68 meters squared. That is the area of 3/4 of the circle, that red area of, so part of the area is called um, what did I try to, what was I trying to say there? The area of the sector. There we go. That's the word. Jack's cow is tied to a beanstalk. Okay, we've talked about this kind of a problem like this. So Jack's cow is right here. It's tied to a beanstalk. So here's the rope or whatever you tie cows to. Here's the cow. Nobody needs me to draw, trust me. How much area does the cow have to graze in? Well, really the area is the radius moving in all directions, right? So here's the center of the circle. The cow really can move in any direction. So it's this entire area. And we know this rope is 15 feet in length, which gives us the radius, and it's 15. That's an easy question. How much area, as long as you know what the picture looks like, you're going to be in good shape here. That's 3.14 times 15 squared. So the area of that region would be 706.5 feet squared is the total area that the cow can graze in. So these are just word problems related to geometry. So that's the learning target we're doing right now. The distance around the wheel of a truck is 9.42 feet. So that's also known as the circumference, is that. What is the diameter of the wheel? So if we're looking for what is the diameter, diameter is measured by pi d. When I need a circumference, I'll just use pi d. We know the circumference. This is going to be a build house, build fence, clean yard problem. 3.14 times the unknown diameter here. What is the diameter? We're going to work backwards. So we're going to build a house around that d because that's what we need to find. No big deal. This is simple algebra here. We're going to divide both sides by 3.14. Coolio. And we get that the diameter is 9.42 divided by 3.14 gives us 3, and the units on that would be feet. So when it says what is the diameter of the wheel, we just found it, that the diameter is 3 feet. All right, here we go. Geometry. Moving to a new learning target. So we just came off the learning target of word problems with geometry. Now we're going to talk volume. So for geometry, volume is measured by the area of the bottom times height for any three-dimensional figure. Doesn't matter if it's a prism, any. So we just have to find the area of the bottom and multiply it by the height anytime you have a figure. So the area of the bottom here would be pi r squared, and then we take it times the height. So that's, you have to transition to that formula kind of on your own. That's the bummer of it. So that's 3.14 times the radius squared. Go find it. Here it is. Radius is 5 squared times the what? Times the height is 10. No big deal. It's just all calculator problems. So it's 3.14 times 5 squared times 10. Gives us 785 feet cubed is the volume. So that is the amount of space on the inside. Volume. Next question, same kind of idea. So when I take the volume of anything, you get volume is equal to area of the base. That doesn't mean length of base, it means area of base. Not sure. I have no idea what this thing is. So we're going to just move that if I can. I don't know where that came from, to be honest. Can I delete it? I don't get it. All right, so we have volume is area of the base, which is pi r squared, times height. So volume then would be 3.14 times the radius squared times height. I ran out of space there. But the diameter is this whole piece, which is 15. So the radius then would be half of that, which is 7.5 and 7.5. So the radius is 7.5 is the radius. And the height is 5. So pi r squared times height. So we're going to type that all in. Is 883.125. Now, if we were to cut that off, that gives us 883.13 meters cubed is the volume or the space inside that cylinder. I'm going to type that in one more time to make sure I have it right. Something feels off. Yes, confirmed. That is your final answer. So now let's talk about how we find unknown pieces, for example. So find the height of something is where we're going to have to work backwards. This is going to be like a build a house, build a fence kind of problem. So you're given a couple things. You're given the diameter is 8, and you're given the volume. You have to find the height. How high is this? So volume of any cylinder is measured by the area of the base times the height. And in this case, it's a circle. So that's pi r squared times height. That's the volume. So we're going to substitute in what things we know. Well, we know that the volume is 176. We know pi is 3.14. We know that the radius must be 4 because 4 plus 4 equals 8. So there's my radius squared, but we don't know the height. No biggie. So we're going to build our house around it. That's how we solve it in algebra. We just build our house around it. Duh. So the first thing I would do is I would multiply all of that out and get it down to one number. Throw 3.14 times 4 squared. And you get 50.24, then multiply by h. So then the last step, of course, is to isolate the h, which we've done a million times. So we're going to divide both sides by 50.24. Copy, paste, copy, paste. So we end up with that h is equal to 176 divided by 50.24 is 3.5 centimeters. So the height is equal to 3.5 centimeters. So that is how we would work backwards. What about this scenario? How much salsa is missing from the jar? So let's take a look at what we know. We know that the radius is 5. We know that this distance is 10, and this distance is 4, which means the missing height is 6, because 6 plus 4 is 10. So how much salsa is missing from the jar? So if we were to highlight the piece we're talking about this section. And I think we have enough data there because we know the height of it, we know the radius of it, so we should be able to calculate the volume of the missing salsa. So using still that pi r squared for the base times the height, and we know that the pi is 3.14, we know the radius is 5 squared, and we know the height is 6. So volume is equal to 3.14 times 5 squared times the missing height would be 6 is 471 centimeters cubed of volume of missing stuff from the jar in this space right here. All right, here we go. So surface area. What is the surface area of the cylinder? This is the formula given right here. Perimeter really means circumference, just a little reminder on that. And we know that the bases are circles here. So surface area. It's 2. Well, I guess I'll backtrack it and use that. It is the perimeter times the height plus 2 times the area of the bases. So that breaks down to the circumference, because they're the same word. So pi d times height plus 2 times the base, which is pi r squared. Okay, so this is what we have for the formula. So it's the circumference times the height, 2 circles, because we have a circle on top and a circle on the bottom. Okay, so now we got to plug everything in. So it's 3.14 times the diameter, which would be 4 plus 4 would be 8. The height is 9. It's just think of the can that the can is kicked over. 2 times pi r, the r is 4 squared. So all of that typed in our calculator, 3.14 times 8 times 9 plus 2 times 3.14 times 4 squared gives me 326.56 inches squared of total surface area, meaning all the surfaces. If we were to wrap that, the outside of that, how much paper would we need? So of like a soup can, but that includes the top and the bottom. Sometimes soup cans don't have labels on the top and bottom. So I would rewind that one a few times and kind of watch how I navigated the idea of what perimeter means. It really means in circles, it means circumference, which is pi d. The height is the same old thing that you're used to. And capital B means the area of the base. And in this case, the area of the base is pi r squared, but you have 2 of them. You have one on top and one on the bottom. Just think of the can kicked over. So you might need to rewind that one a few times just to make sure you're ready for the test. So what about a question like this when we're only going to label this piece right here? So let's start off kind of what we just used in the formula. So surface area is the perimeter times the height plus 2 times the area of the bases. Okay, so the perimeter is the circumference, pi d, times height plus 2 pi r squareds. Okay, but we are not going to put any paper on the top circle or the bottom circle. How much paper is used for the label of the can? Just the cat food label. So we actually are not going to need to put any paper on the top circle and the bottom circle, those pi r squareds. So this is going to turn out to be a nice little problem here. So that's 3.14 times the diameter, which becomes really 30 plus 30 is 60, and the height of the can is 24. So this is just for the label. How much for the label? Nothing on the top circle or bottom circle. So 3.14 times 60 times 24 is 4,521.6 millimeters squared, the total area of the label. All right, next section is on translation, which is part of the learning target here. So when we translate the figure, we have to translate the x and we have to translate the y. So if we think of our x movement, we're moving from 3 to 1, which means that we're decreasing 2 units. And when we go from the y, which is -2, and we translate to 0, we're also increasing. Or I guess the first time we were decreasing, my fault. We're increasing 2 units because we're going from -2 up to 0. So this would be the description of the translation using like algebraic way to describe. I lost my pen. All right, here we go. X, Y. What's the translation? Start with the X. When we translate the X, we go from -8 to -3. We're getting bigger or smaller. You should be thinking bigger. We're getting out of the hole here. How much did we grow? 5. Let's take a look at the y's. We're at -4. We go to +5. Do we get bigger or smaller? You should be saying bigger. How much do we grow? 9. So there is the translation of your xy coordinate. So now what about reflection? The coordinates of a point and its image are given. Is the reflection in the x-axis or the y-axis? So let's plot these points. Okay, so we'll call this A and A prime. This is the exact same problem you did in our other lesson. So we're going to go right 2, down 2. There's A. And then we're going to go right 2, up 2, right 2, up 2. There's B. That's not what I meant to say. I think I did that exact same error in the other video. That would be what we call in math A prime because it's the image. And we're going to reflect it so that they land on top of each other. We would say in this case that we're reflecting over the x-axis. X-axis. So now let's do the other coordinate we'll call B and B prime. So B is located at -1, 2, 3, 4, up 1, which is B. And B prime is located at 1, 2, 3, 4, up 1, which is B prime. And we're going to reflect that in the y-axis. So that's a reflection. We want to make sure it's the same distance from the line. We want to make sure that they fold right on top, and so on. So I might have hit all the learning targets. Yay! So that is your learning targets for the geometry unit coming up. Make sure you're ready for that test. Have a glorious night.